is Algebra 2, excuse me, lesson 9.4, multiplying and dividing rational expressions. That's what we're doing today. We're multiplying and dividing. We're going to look at real life quantities using rational expressions. Beginning on page 554, you have a definition to start. What is a simplified form of a rational expression? It is simplified if the numerator and the denominator have no common factors other than plus or minus 1. So what that's saying is when you look across the problem, if something is exactly the same at the top, like x plus 1, as it is at the bottom, x plus 1, you're going to eliminate that and that. So if there's not something that's exactly the same at both the top and the bottom, once the top and bottom are completely factored out, then it's considered simplified. This is one of those lessons. This is one of those math skills that it's going to take you a while. It's going to take you a bunch of examples before you recognize when something is totally simplified. Sometimes you're going to think you're done with the problem, and you won't be. And sometimes you're going to think that you have a whole bunch more to do, and you'll actually be done. And I'll show you as we go through those the difference between those two. But first things, this is not on your sheets. I need y'all to copy this down real quick. Copy it in the margin or copy in the middle of the two sheets or stick it on the back. Fit it somewhere. This is from a lesson. We actually skipped this part of one of our lessons earlier on. We need this one for example number 3. We know how to factor trinomials into two binomials. We know how to factor the difference of two perfect squares. This is factoring the sum of two cubes and the difference of two cubes. So the first one is the sum of two cubes. So we have the sum of two cubes first, a cubed plus b cubed. What that is it's going to be a binomial first right here. It's going to be a binomial where you're going to take a number that makes up a that you can multiply right here times a number that makes up a. Okay, and when I put numbers on that instead of variables in this case, it'll make a little bit better sense. But and you're going to do the same thing with b, a number that makes up b times a number that makes up b way over here. What goes in between them is what's important. Since it says the sum of two cubes, you're going to put plus in the middle of it. And your b squared value in your trinomial after it is going to be positive. That's this one here. But where a multiplies times b, that's going to be the opposite sign right here. Notice this one is negative. So again, just to recap that, a cubed plus b cubed is equal to a plus b times a squared minus ab, that's where the opposite sign comes in, plus b squared. Let's look at that with some numbers to make that make a little bit better sense. X cubed plus 8. 8 is a number that you can cube something to get to it. You can cube the number 2. So 2 cubed. So notice right here, this b value, 8, 2 cubed is what makes it up. So again, it's x plus 2. And x cubed makes up x cubed. I know that sounds funny to say that, but x times x times x. That's why it's just x to the first power adding to 2. Then what you need to ask yourself is what number or what do I need to multiply x by to get x cubed? You need to multiply it by x squared. And what do I need to multiply 2 by to get 8? You need to multiply it by 4. So it's just like factoring out a binomial. So you have x squared and you have plus 4 at the end. Again, the sign in between them, or the one that is in front of AB, where they're multiplying by each other, is going to be opposite. It was x cubed plus 8, the plus in between, so the minus goes in front of your B value and your trinomial here. Minus that same number 2 times that same number x. So this is coming from this. Again, let's look at the exact same thing with subtraction, and you'll see that when it's subtraction, everything's just flipped, but it's the same pattern. The difference of two cubes, a cubed minus b cubed. Again, that first binomial is going to be a minus b, the same sign. Then the sign in front of b, this one right here, is going to be the opposite. It was minus between a cubed and b cubed. That's plus there. What number do you need to multiply by a to get a cubed? You got to multiply by a squared. What number do you need to multiply by b to get b cubed? You got to multiply b squared. Again, let's look at some numbers to make that make sense. 8x cubed minus 1. This is the difference of two cubes, because you can cube something and get the number 8. You can cube the number 2. So notice in your first binomial, it says 2 times x, because you can cube the number x to get x cubed. And you can cube the number 1, or you could multiply it by itself 3 times. You can cube the number 1 to get 1. Then you just ask yourself, what do I need to multiply 2x by to get 8x cubed? You need to multiply it by 4x squared. And what do I need to multiply negative 1 by to get negative 1? You need to multiply it by positive 1. Again, in the middle, since it was the difference of two perfect cubes, this is the opposite sign right here, plus. And then that's going to be a plus b, or positive a times b, 2 times x. Again, we have one more example that'll show up that uses that one, but we needed to cover that to where we weren't lost on special factoring patterns with the sum and difference of two cubes. Now, this is on your sheet, simplifying rational expressions. Let a, b, and c be non-zero real numbers or variable expressions. Then the following property applies. If a is multiplying by c and b is multiplying by c, then c is the same at both the top and the bottom. And if it is, in the numerator and the denominator, it can cancel itself out. C cancels out c. You're left with a over b. Example number 1 says x squared minus 2x minus 3 over x squared minus 9. So we have a numerator and a denominator that we can factor. We can factor out the trinomial x squared minus 2x minus 3. We know we can make two binomials out of that, x times x. And 3 only has one pair of factors, 3 and 1. You know 3 and 1 make up its factors. This sign tells us that they're opposite signs. This one says the bigger number is negative. 3 is the bigger number, so it's negative. They're opposites, so it's plus 1. Over, we can factor the bottom fraction, or the bottom of the fraction. It's the difference of two perfect squares, like the one we did on the bell work. Take the square root of the first one, it's x, and the square root of the second one, it's 3. X and 3 for both of them. X and 3, 2 of them. This one, since it's the difference of two perfect squares, one is plus 3, one of them is minus 3. Once you have it factored out like this, you're just looking for the exact same thing at the top and the bottom. Okay. Notice at the top and bottom, we have x minus 3 for both of them. We have this one and we have this one, so we can cancel them out. So what are we left with? We're left with x plus 1 over x plus 3. This is your simplified form. And I know you can clearly see that x is exactly the same at the top and the bottom. You can see there's an x and there's an x. But remember, fraction bars act like parentheses. So before multiplication and division is done, you would have to add 1 to the x on top, and you would have to add 3 to it. Therefore, they're not the same number, and you can't factor out that x over x. So it's simply, this one's answered, and this is what I was telling you when we first opened up this lesson. This one's answered is x plus 1 over x plus 3, and it kind of feels like you have to do something else to it, but that's it. But you can go back to this one if you're not sure. Is there a common factor at the top and bottom? If there's no common factor, then it is considered simplified, x plus 1 over x plus 3. In the margin or on the back, do this one. I'm going to do it just like example number 1. X squared minus 5x minus 6 over x squared minus 1. Very simple. It's almost an identical example to number 1. Take about 45 seconds. So what we're going to do is we're going to factor the numerator, we're going to factor the denominator. The numerator is a trinomial, so we'll factor it and make it the product of two binomials. X squared separates into x times x. Your C value 6 has two pairs. It has 1 times 6 and 2 times 3. Both of those give you B's value 5. But remember, the sign in front of C, -6, means that you have to subtract the numbers to get to it. You have to add 2 and 3 to get to the number 5, so that pair won't work. We have to use 1 and 6 to subtract them to get to the number 5. Again, that sign in front of C also tells you, since it's negative, that they're going to be different signs. Since they're different, this one tells you the larger one. 6 is larger, so it's negative. 1 is smaller, so it's positive. So x plus 1 times x minus 6, that's factoring the numerator. When we factor the denominator, it's the difference of two perfect squares. You can take the square root of x squared and get x, and you can take the square root of 1 and get 1. So we have x and 1, and we have x and 1. Remember, it's the difference of them, so it's one's plus 1, the other one is minus 1. Once it's factored, all you do is eliminate or cancel out the things that are exactly the same at the top and the bottom. X plus 1 is the same at the top and the bottom, so it cancels out, and it leaves you with x minus 6 over x minus 1. This is your simplified version of that trinomial divided by that binomial. On our checkpoint problems, it says x squared plus 2x minus 15 over x squared plus 6x plus 5. All we need to do is factor the top, factor the bottom. Take 45 seconds, see if you can handle that one. Okay, another easy one to factor, just two trinomials. X times x gives you x squared. Your factors of 15 are not very many. You can use 1 and 15 or 3 and 5. The only pair that gets you to 2, the B value, is 3 and 5. This sign says they're opposites. This sign says that the bigger one's plus. So plus 5 minus 3. For the bottom one, we'll do the same thing. X times x gives you x squared. You only have one pair of factors to get to C's value 5. You have to use 1 and 5. This sign says that they're both the same, since it's plus. This one says they're both positive. So plus 1, plus 5. Then you can clearly see what's exactly the same at the top and the bottom, x plus 5 and x plus 5. So that's what you're left with, x minus 3 over x plus 1. Example number 2 is multiplying rational expressions. It doesn't matter that it's multiplied. This is one of those steps that it almost doesn't matter until the very end. 3x squared plus 6x times x minus 4 over x squared minus 4x times x squared plus 9x plus 14. Notice how I read it. I read the whole numerator, then I read the whole denominator. So what we have is you can multiply straight across in order to factor, or you can try to factor first. So notice if we just factor 3x squared plus 6x, the thing that they have in common is 3x. So if you take 3x out, then you ask yourself, what do I multiply 3x by to get 3x squared? The answer is x. So it's 3x times x. And what do I have to multiply 3x by to get 6x? I have to multiply it by positive 2. So remember, it's like the distributive property backwards. The other side of the numerator says x minus 4. That part doesn't change. On the bottom, when you factor it out, you can take the x out of the first one. They have that x in common. And you're left with, again, what do you multiply x by to get x squared? You multiply by x. What do you multiply x by to get negative 4x? You multiply by negative 4. So you have 3x times x plus 2 over x times x minus 4. When you factor out the trinomial on the second one, you multiply x times x to get x squared. Then you factor a 14, or 1 and 14, and 2 and 7. The only pair that gets you to b, the only pair that gets you to 9 is 2 and 7. So you got to use 2 and 7. Again, the sign in front of 14 is plus. That tells you they're the same. The sign in front of 9x is plus or positive. That tells you that they're both plus. So now, look at everything that's written up here right now. Anything that's the same exact thing at the top and the bottom right now, at any point during the problem, you don't have to wait till the end. Anytime something's exactly the same, you can cancel it out. So right now, we have x plus 2 and x plus 2. And we have x minus 4 and x minus 4. So now look what we're left with on both the top and the bottom. We're left only with 3x at the top in the numerator, and we're left only with x times x plus 7 in the denominator. So all of that, all it did was put them together. What I told you a second ago is anytime something's exactly the same, you can cancel it out. So you don't have to wait till the end. So again, notice 3, and then what we did right here is I didn't take out the 3x over x. That is also exactly the same. X times x. Now it looks even better. 3 is the only thing at the top, and x plus 7 is the only thing at the bottom. Or 3 is in the numerator, and x plus 7 is in the denominator. Again, all they did is they waited till this next step, and they did it here. X minus 4 over x minus 4. Again, all this example, it's just canceled out at that step right there. X minus 4 over x minus 4, x plus 2 over x plus 2, and then x over x. So 3's left at the top, x plus 7's left on the bottom. On the back, on the side, one more time. X 6 times x squared y cubed over 2xy, x squared y squared times 10x cubed y to the fourth over 18y squared. Again, with a problem like this, Anytime you have something factored out, or anytime you have something isolated that's the same at the top and the bottom, or the factors are the same, you can cancel them out. What I mean by that is if you look at just this first fraction, 6 is divided by 2. That number 2 goes into both of those. It goes into itself once, and it goes into 6 3 times. So right there, I got rid of that right there. The same thing with 10 and 18. The number 2 goes into both of those. It goes into this one 5 times and into this one 9 times. So you can factor it out at any time. Same thing with x squared for the first one. It's exactly the same as this one. That cancels out. The rest of it, if we go ahead and put it together at this point, 3 times 5 on top is 15. Y to the third times y to the fourth. Remember, anytime you multiply bases, you add exponents, 3 plus 4. At the top, that gives you 15y to the seventh. On the bottom, we still have the number 9. We didn't cancel that one out all the way, 9. We still have y squared and y squared. Again, you add 2 plus 2. So what we're left with is 9y to the fourth. The number 3 goes into both 15 and 9. It goes into 15 5 times and into 9 3 times. And y to the 7th divided by y to the 4th, you subtract them. 7 minus 4 gives you y to the 3rd. This is simplified, 5y to the 3rd over 3.